Hello, Matthews Gatos here. Welcome to this video for 2.7. We are going to look at how do we solve problems not involving just one, but two, maybe even three right triangles. So what are we going to do? With these questions here, your calculations are probably going to involve a couple steps. We're not just going to do it in one step. My tip to you is look for something they have in common, any common sides or angles, because you're probably going to use those. And most importantly, do not round until the last step. So I'm going to show you a cool little function on your calculator using a store function as an option. That's always a good one. So let's get started. Let's try this one here first. So I want to calculate angle DCB. So that's this angle right here to the nearest tenth. So before I start doing any calculations, I always like to kind of come up with a plan. So looking at this triangle here, I don't have buckets of information, but I'm really focused in on this triangle here because that's where my angle is. So looking at that triangle there, I have a side, which is great, but I need another angle or perhaps another side. So this is where the common side comes in. So looking at it, I can see that this side here is common to both triangles. So step one, I'm going to find side DB. Once I find side DB, I now have two sides in that triangle, and I can use that to find the angle. So then I'm going to, in this two-step problem, find angle C. So let's go ahead and do that. So let's just erase this mess that I made, and let's start with step number one, finding side DB. So looking at this side here, I'm going to look at the triangle on the left. So I see that I have an angle 35 degrees. I have a side that is opposite, and I want to find the adjacent side. So O and A, that is TOA. So I'm going to TOA, tan. So I'll write down that tan of 35 degrees is equal to opposite 5 over adjacent, which I do not know. So I'm going to make this as a fraction on both sides, circle my variable, and then I'm going to cross multiply and divide. So on my calculator, I'm going to do that A is equal to 1 times 5 divided by tan of 35. And then I will use that to find the angle on the other side. So let's go ahead and do that on our calculator. 1 times 5 divided by tan of 35. So 1 times 5 is 5, and I'm going to divide that by tan of 35. Okay, now you can always just leave it there because on the newer calculators you can go up and you can grab any number that you want. But I'm going to show you another option, particularly those of you that have the 83, you might like this option. What we can do is we can store that value in a letter. So remember how we used A for that, A for adjacent? Here's what I'm going to do. I'm going to go ahead and store. So on the side here, the very far left-hand side, second row from the bottom, right above the on key, see how I have a store key? So I'm going to store that answer into any letter I want. So I'm going to choose A because A for adjacent. So if you look on your calculator, all the green little things there are letters. And I see that A is at the very top above my math button. So see above the math button, I have a little alphabetical A. I'm going to store it in, I have to hit alpha to get into my alpha keys, which is alphabet, math. So see how that says store it in A? When I press enter, it's now stored in parameter A. So I'm good to go. I'm going to leave it there for now. So I know that A is approximately 7.1, but we're not rounding to the last step. Okay, so I've done my first step. I found DB. Now let's go ahead and we're going to find angle C now. So for angle C, I'm going to go into my other triangle. So to find this angle C here, I now have a side and another side. So looking at that angle, again, it looks like I have opposite over adjacent, so I'm using tangent again. So tangent of angle C is equal to opposite, which is my A value, over adjacent, which is 12. Now, I know that that's about 7.1, okay? But I don't want to round until my last step. So here's what I'm going to do. to find out what my value is, I'm going to take my ratio and I'm going to go backwards. If I want the angle, I need to use my inverse keys. So tan inverse of A, which is about 7.1 over 12. So I'll show you two ways that you can figure out what angle C is. So tan inverse of about that 7.1 over 12, or we're going to use our store key, and I'll show you how to get the same answer. So back into my calculator, and I want to do tan inverse, so second tan. Now if we have a newer calculator, we can actually go up here and just grab that value, and I'm going to divide it by the 12. So divide by 12. And there we go. There is my angle that I'm looking for. To the nearest degree, it would be 31. Now, if you can't have the capability on the calculator to go up and grab it, here's where your store is going to come in handy. I'm going to do the same thing. So second tan inverse. And instead of 7.1, let's say I can't grab that, I'm just going to use where I stored it, which is in A for adjacent. So I'm going to go alpha math, because that's where A is. So we're doing the tan inverse of A divided by 12, and we should get the same answer. And you can see that we in fact do. So two different ways that you can do that. So back to my notes, what did they want us to round to? To the nearest tenth. So I'm going to take that number, 30.7, look at the right of 7, it's a 5, that tells me to round it up. So it will be 30.8 degrees. And then I'm done. Okay, let's try another one. So for the next one that I'm going to tell you about, we need to know some of these words, angle of elevation and angle of depression. So we've talked about angle of inclination. It's the same thing for angle of elevation. So angle of inclination was an angle above the ground. Angle of elevation is the angle above a horizon. So usually the horizon is some sort of a line of sight. So when we talk about angle of elevation, it's usually we're looking up at something or we're looking down at something. So that horizon is usually a line of sight. So we can have angle of elevation, elevation means above, or an angle of depression, which means below. Now, whether I'm given an elevation or a depression angle, I always want to work with the angle of elevation because it's inside the triangle. So here's an example. We have an air traffic control and we have an airplane. So the airplane looks down at the air traffic controller at an angle of depression, and the angle of elevation is from the air traffic controller to the pilot, but those angles are the same. Think about parallel lines. Those are alternate interior angles, those Z angles. They are always equal. So if I've given you an angle of depression on the outside of a triangle, I just want you to put it on the inside at the base as an angle of elevation instead, because we want to work inside our triangle. So here's an example. We have this tower, and a fire ranger is looking at a fire due west and another one due south. So here's the angle of depressions. From his line of sight, he's looking down at one fire at 5 degrees and down at the other fire at 2 degrees, and we want to know how far apart these fires are. So if you look at this on the diagram that they've given you, the angle of depression of 5, if you use that Z property, is the same as the angle of elevation there. Same thing here, angle of depression of 2 using those Z angles. I know that this is also an angle of 2. Now, the tower itself right here is 90 feet, and we want to know how far apart those fires are. So what we need to do is find, based on these triangles here, the base angles. So I've got these two triangles here. This has a height of 90. If I can find this side and I can find this side, that will make a new triangle where I can find the distance between the two. So this is going to be a 3-step process. I'm going to find side X in the left triangle. I'm going to find side Y in the right triangle, and I'm going to use those in a third triangle, and I am going to find the distance between the fires. So find the fire distance. So we're going to have to do this in 3 steps. So let's start with step number 1. So step number 1, I'm going to do this side here first, the side to find out X. So looking at that, I have a 5-degree angle. Obviously, this is not drawn to scale, and side x. So looking at that, I have an opposite and an adjacent, which is tangent. So I'm going to do tangent of 5 degrees is opposite over adjacent. Put that over 1. I'm going to cross multiply and divide. Now this might be a case where we do want to use that store function that I just showed you. So I'm going to do 1 times 90 divided by tan of 5, and that will give me my x value. So let's go ahead and do that on our calculators. So 1 times 90 divided by tan of 5. 1 times 90 divided by tan of 5. Okay, so we've got that answer there, and we are going to store that in, I'm going to call it x because that's the variable that I chose. So I'm going to go store, and I'm going to put it in alpha, and I look for the green ones where x is. So alpha x is above your store key, so I'm storing it in x. So I know x is about 1029, but I'm not going to round until the last step. Okay, so right now I know that x is about 1029. Okay, now let's go up and do the same thing. We've found x. Oops, we've found x. So now let's go ahead and find y. So to find y, I'm going to go to the other triangle on this side here. This is 2 degrees, 90, and I want to find y. So again, this is opposite over adjacent tangent again. So tangent of 2 degrees is equal to opposite over adjacent. Put that over 1, and I will cross multiply and divide what's left. So 1 times 90 divided by tan of 2, and that is what my y value will be. And again, we can store it into our calculator. So 1 times 90 divided by 2, tan of 2. So putting that into my calculator, you see I get about 2,577. Now I'm going to store that because we called that y. I'm going to store it in y. So again, store, and I'm storing it in my parameter or my letter y, so alpha, and I see y is above number 1. So I'm storing it in number alpha 1, which is y. So let's put that over here, and that's about 2,577. So not equal to, because I'm rounding, but approximately. Okay, so now I have, let's go back to our plan here, I found side y. So I'm going to put that together and find the fire distance. So I'll give myself a little bit more room here. Okay, so now I want to find the distance between the fires. So now I have my third triangle, which is right, oops, let's try that again. My third triangle, which is right here. So I'll come down here, and it's made up of side x, side y, and then I want to find the hypotenuse because this is the distance between the fires. So we know that x is about 1029. We know that y is about 2,577, but again, we are not using the exact values. We'll do that on our calculator. So x squared plus y squared will equal to c squared. So I'm actually going to go on to my calculator to do this. Now, you already know how to go up and grab the numbers if you have one of those calculators. I'm just going to do it with my alpha parts. So I'm going to pull up alpha number store, which is x, and I'm going to square that, plus alpha number 1, which is y, squared, and this will give me c squared. Now remember that is c squared, not the square root. So I do need to take the square root, so I will vans that. Square root of the answer, our famous math brand vans. And there is my final answer. So how do they want us to round this? Let's go back over here, go all the way back up. They want us to round it to the nearest foot. So I know that c is going to equal to 2,775 because the 9 tells us to round it up. So 2,775, and our units are feet. That's how far apart they are. So not rounding till the last step because it increases the accuracy of my answers. So you guys can do that using the store function or just go up and grab your values, whichever way you want to do it, as long as you're not rounding until the last step. So dad says, or the kid says to the dad, Dad, it's so cold in here. And the dad tells him, go stand in the corner. The kid's thinking, did I do something wrong? What's going on? Why is dad getting me to stand in the corner? Does anyone have any idea why dad would tell his son to stand in the corner? Well, it's because corners are 90 degrees, just like right triangles. So I hope this video helped, and I do look forward to seeing you guys for the next one.